Good morning. This is Neil Polhemus. I'm happy to welcome you to our first webinar of this fall series. And it's definitely my pleasure to begin the series by introducing to you all of the things that we've put in the latest version of Statgraphics, which is Statgraphics 19. Statgraphics 19 is the 19th version of the program. We introduced Statgraphics actually way back in 1980. So it's been now about 40 years that we've been developing Statgraphics. And this particular version, version 19, has been almost 3 years in the works. And I think you'll see that there's quite a bit of interesting things that have been added to the program. Now, what I'm going to be doing here today is talking pretty much about the general new features that we've added. I have additional webinars scheduled pretty much one every 2 weeks this fall to go into some more of the details about the statistical procedures. Today, I'm going to give you a fair overview of what has been added. Now, there are two primary changes that you'll see compared to version 18. First off, there are changes to the user interface. And secondly, there are additional procedures and enhancements to current procedures. In terms of the user interface, the first thing you'll see, and I'll show you the program in just a few minutes, is that we've added a ribbon bar. We've gone away from the old pull-down menu style bars and added instead a ribbon. We've also relocated the system toolbar and put it above the menus. We're now going to be calling that the quick access toolbar. You'll see changes to some of the tab dialog boxes, things like graphics options and system preferences, that sort of thing. You'll also see a brand new option in our analysis windows to show output as a single pane. Those of you who have used the program before are used to our multiple pane view, where you have various graphs on one side in their own windows and tables and so forth on the other side. We still have that multiple pane layout, but now there's an option that allows you to switch to a single report style layout by just pushing a particular button. We've also added to the program something called a dashboard. A dashboard displays tables and graphs with alerts. It's like our stat gallery, except that the alerts are shown by coloring the backgrounds either green, yellow, or red. And I'll illustrate that a bit for you. In terms of the procedural enhancements, we've added 15 new statistical procedures. We've added enhancements to 40 existing procedures and modified the tables so that we have nice column and row headers. We've given the ability to make the background of graphs transparent so that you can see through them, see what's on the background. That's typically if you copy into something like Word. And we also have the ability to save images to file from the stat gallery. Oh, and one important feature, and I shouldn't forget this, is now an interface to Python. In previous versions, we had an interface to R, which is a free programming language. we still have that, but we've also added now an interface to Python. Okay. Now, let me show you what it looks like by calling up Statgraphics. Okay, I want to forge ahead here. What you're looking at now is the new interface for Statgraphics 19. You'll see some familiar things like a data sheet in the middle of the screen, a navigation bar on the left-hand side. What's new, of course, is the ribbon bar here at the top. Rather than having pull-down menus, as you scroll through the different options, which are pretty much the same as they were before, describe, compare, relate, and so forth, you'll see that the options are all laid out on the ribbon bar. I think it makes it a lot easier for people to find what they're looking for. And it also gives it a little bit more of a modern interface. The system toolbar, which used to be below the menus, is now at the top. You have the same sorts of options that you had before for okay. Okay. Mike, does that look a little bit better? I just got a message that somehow the screen had stopped sharing. All right, so let's take a look at this again. This is what the main toolbar, main window of Statgraphics looks like. It has a data sheet in the middle. It has a ribbon bar across the top. Now, I'm sure it makes a little bit more sense and you can see it. We have the same sort of options that we had before, as I was saying. We have file, home, edit, plot, describe, compare, relate, and so forth. But you can see if I click on something like compare, all of the statistical procedures for comparing samples are laid out on panels. So there's a panel here for comparing two samples, one for comparing multiple samples, one for doing an analysis of variance, one for doing equivalence and non-inferiority tests. Yeah, there are a couple tabs that are new. You'll see that there's a home tab, and we've taken all the things like system preferences and window layout and help system and so forth and put it on the home tab. There's also a new interfaces tab on the right-hand side where you see the interface to R and to Python. Okay, so I think I happen to like this layout. It may take you a little bit of time to get used to it. A few things did get moved around, but if you look at it, I think you'll, once you play with it, really get to like it. Now, I'd like to show you how the program works. So I'm going to go over to File, and you see here some of the recent files, Statfolios and data files that I've been working with as I prepared this particular webinar. What I've called up here is data from the COVID-19 tracking project. You see in the first column here, dates. And what we have is information about COVID-19 going back to January 22nd through, I believe it's the end of October. The data in this particular file that I'm going to use to illustrate how Statgraphics has changed a little bit has columns like the number of positive tests, the number of people currently hospitalized, the number of people in ICU, and information like that. Okay, first thing I'm going to do is I'm going to go to the time series section and ask for an automatic forecasting model. Let's go ahead, let's take the number of people hospitalized because of COVID-19 and put that in for the data. The time indices are in the column called date, and I'm going to ask the program to forecast the next 30 days. Okay, now this is all the same as it was before. Oh yes, and I'm being reminded that the data I'm looking at is data for the United States. It's the number of people in the hospital in the United States. Okay, I'm going to ask it to try a bunch of different models. And you can see this works the same as it worked before. You have the data input dialog box, then you have the analysis options dialog box, then you ask for tables and graphs. And when I press OK, the program is going to open an analysis window in the same sort of mode that it did in version 18. One thing you will see, if you look, for example, at the analysis summary here, is we've spruced up some of the tables. You can control, in fact, the layout and colors of the columns and rows in tables. It makes them look a little more interesting. Now, incidentally, if you'd like to see a plot of the number of people hospitalized in the US, you can see that there weren't really anybody in the hospital until the end of March. Then in the US, we had a spike in the spring, went down for a while, went back up in the middle of the summer, went down in September, and unfortunately is headed back up again. Okay, now that's the standard layout. On the ribbon bar, you'll see a button labeled switch. Now what switch will do is it will switch from the old multiple pane layout to our new single pane layout. And here you can see it's taken all the graphs and the tables and put them in a report style format. Okay, that's more like it would look if you printed out the analysis. And again, if I want to, I can always switch back and forth from multiple pane mode to single pane mode. In order to do that before, you would have had to have taken the entire analysis, copied it to the stat reporter, and then you would have had that layout. Now you can just switch back and forth with the switch button. Okay, that's one of the major changes. Another major change is the way we've laid out things like graphics options. If you're familiar with graphics options, it used to be a tab dialog box where there'd be a particular tab for layout, a tab for grid, a tab for lines and points and so forth. We've changed the format of that, which makes it just a little bit easier to use. Now, one of the other interesting things that we've added to the program is something called the dashboard. The dashboard is a place where I can take tables and graphs and paste them. And unlike the stat gallery, I can paste both tables and graphs. Now, let me start by doing a little bit of a regression here. This, I think, is a pretty good illustration of how the dashboard is to be used. I'm going to ask the program to fit a simple regression model. And I'm going to take the number of people that are hospitalized on any particular day because of COVID and regress that against the positive percentage. That's the percentage of tests which are coming back positive. Okay. And what you'll see if I go through, I'll just take all the standard options, is the regression. Oh, now one thing I should have done, let me go back to data input. It's a little bit better if I ask for date greater or equal to 5/1/20. Some of the early observations don't follow the same pattern as those later on. Oops, and it would be nice if I just put 1 slash in the date, not 2 slashes. That's a little bit better. Okay, that's the regression I really wanted. A fairly strong relationship between the number of people hospitalized at any particular time and the percentage of tests that are coming back positive. Okay, now, what I want to do though is illustrate how the dashboard works. So what I'm going to do is I'm going to start with this table here, push the right mouse button, and ask to copy that to the dashboard. And then when I go to the dashboard, I'll use the right mouse and say paste link. Now you'll notice what it did is it put the table into the upper left-hand corner and colored the background red. Now let me actually change the layout here. I think I'll ask for simply 1 row and 2 columns. And that's a little bit better, because I also want to take this graph here and paste that next to the table. And you'll see the background of the graph is also red. Now, why is it red? Well, if I go up to the ribbon bar here and ask for properties of the dashboard, you can see that at the moment, the dashboard is set to color red any regression analysis that has a standardized residual greater than 3. Okay, so the fact that these are coming up red at the moment indicates that there must be at least 1 studentized residual greater than 3. If there was none greater than 3, but there was 1 greater than 2.5, it would have come up yellow, and otherwise it would have come up green. Now you can actually see that. If I go back here, for example, look at the residual plot. Here's the guy right here. Oh, here's another change. When I put the left mouse down on a point, you'll notice that information about that point is displayed right below my mouse. Okay, and you can see, if you look closely, it says Y is minus 3.0. Well, let me go up to the top menu and ask it to take out that point. And now you'll see when I go back to the dashboard, everything is back to yellow. I still have some points more than 2.5 standard deviations out, but I don't have any points more than 3 standard deviations out anymore. Now, the idea, and the reason we call this the dashboard, is we expect people to paste information from lots of different analyses in different locations of the dashboard. And I can imagine someone coming in every morning, opening the Statfolio and checking all the graphs and tables in the dashboard to see which are yellow, which are red, and so forth. Now, you may have noticed that there are a number of other procedures that we can set to give alerts. We can define, for example, alerts for control charts. Red, for example, if there's a point beyond the control limit. Yellow if there's a runs rule violation. We have some settings for gauge R&Rs, for capability analyses, for stock charts, and also for a dashboard gauge. This is something that people had asked for, and I think it works pretty nicely, automatically coloring the background yellow, red, or green. Okay, so those are a few of the changes to the user interface. I now want to show you some of the changes we've made to the statistical procedures. Okay, and that's, I had some slides. Oh, incidentally, I'm going to post these slides for you on the website together with the recording of the webinar once we're done here. And these are some of the things I just showed you. Okay, now in terms of what we've added on the statistical side, we've done quite a bit of work in terms of fitting distributions. You know that Statgraphics has a very large number of distributions that you can fit to data. We've added a number of other interesting ones. One of the things we've added is the Johnson family. Johnson distributions can match the first 4 moments of any sample of data: the mean, the standard deviation, the skewness, and the kurtosis. Very flexible set of distributions. And I'll show you an example in just a moment of one. We've added a couple discrete distributions, what are called the zero-inflated Poisson and negative binomial distributions. Therefore, count data which have excess zeros, more zeros than would be expected. I've seen that actually quite a few times in practice, where you have a nice distribution, but you've got a whole lot of extra zeros. And those distributions put in an additional term to allow the number of zeros to be greater than you would expect, given the rest of the distribution. We've also added the ability to fit mixtures of normal distributions. That's typically for data with more than one mode, and I'll show you a couple examples in a minute. The other thing we've done is added the ability to fit any probability distribution when you have a combination of different types of censoring. Now, we could handle censored data before, typically if you had only left censored data or only right censored data. What we have now is the ability to fit distributions where you have any combination. You can have some censored on the left, some censored on the right, and also interval censored data. Interval censored data is where all you know is the actual observation falls within some limits. Okay, now here's an example where I've taken the car data, the 93 cars that I've looked at in lots of different webinars, and ask it to fit a Johnson distribution. Now, there are actually 3 types of Johnson distributions. There are the bounded distributions, there are the unbounded distributions, and there's the log normal distribution. What the procedure does is it automatically figures out first what type of Johnson distribution to use, and then secondly, estimates the parameters. In this case, it fit what is called a bounded distribution, a Johnson SB distribution. And you can see that that particular distribution has a locations parameter, a scale parameter, and 2 shape parameters. Again, that enables the distribution to match the mean, standard deviation, skewness, and kurtosis of the data. So it's a 4-parameter distribution able to match the first 4 moments. The zero-inflated distributions, as I said, are very useful for count type data that have excess zeros. Now, one of the data files we ship with Statgraphics has fish counts from various places in the Gulf of Maine. Basically, fish counts, I believe it's on a yearly basis. And this is a histogram of what the counts look like actually in the Bay of Fundy. Often when they go out to count fish of a particular type, they don't see any. And you can see a big bar here at the bottom with lots and lots of zeros. When they do see fish, sometimes they see 1, sometimes they catch 2, 3, 4, 5, and so forth. With a zero-inflated Poisson distribution, you basically have a Poisson distribution for the data which is greater than 0, and then in excess, what are sometimes called structural spikes for the excess zeros. So it's interesting how often that type of data comes up, where you'd like to fit a distribution, but the zeros make it typically unfittable. So they're called zero-inflated distributions. As I mentioned, we also can fit mixtures of normal distributions. This is an interesting data set. This has to do with the duration of eruptions of the Old Faithful geyser in Yellowstone National Park. It's been well studied, the duration of the eruptions of Old Faithful, and it turns out that there are some eruptions, quite a few, that have a mean of about 2 minutes, and then other eruptions that have a mean of about 4 minutes. No single distribution is going to be able to model that type data. So what we have here is instead the ability to fit a mixture of Gaussian distributions. Now, basically what you do is you tell it, I think there are 2 modes. And then what the program will do is it will estimate 2 means, 2 standard deviations, and also determine the proportion of the data that goes into each of the 2 components. So it allows us to fit data which we simply couldn't fit with any of those other 45 distributions. Now, someone was looking at this yesterday and noted that perhaps the lower distribution here is not a normal distribution, not Gaussian, and that's certainly possible. So I think in the future we'll have to look into fitting mixtures of non-normal distributions. But right now in version 19, it's a mixture of normals. And we can do it for univariate data. I'm sorry, let me go back up. And we can also do it for bivariate data. There's another set of data that's shipped with Statgraphics that has to do with measurements of body temperature and heart rate. And you can see in this case, when I try to fit a bivariate normal distribution, again, one single normal distribution is not going to do a very good job because there are definitely 2 peaks in this particular data. So we can fit both univariate and bivariate distributions. We can also, as I mentioned, now fit data with arbitrary censoring, data that has a combination of left, right, and interval censoring. This happens to be a scatter plot of the number of days having to do with some particular medical procedure. There are observations which are left censored, meaning we know that they're less than a particular value, but we don't know how small they actually are. We have some observations here which are right censored. We know they're at least a certain amount, but we don't know how big they are. And then you can see some lines like this in here, where what we know is that the observation falls within some range, but we don't know where in that range it falls. So we can take a univariate distribution with all 3 types of censoring and come up with a fit. This is usually used when you're doing life data analysis, looking at reliability, time to failure, that sort of thing, is where you'd often come up with censored data. Another area of Statgraphics which is quite extensive is the sections on regression and analysis of variance. Seems like every time we come out with a new version, we add a few more features in those particular sections. In version 19, some of the new things we've added, well, first off, we've added something called a quantile regression. You know, typically when you're fitting a regression model, you're modeling the mean of the dependent variable. There are other times when, rather than modeling the mean, you might be interested in modeling the 90th percentile. Well, a quantile regression will fit models for different quantiles, different percentiles of the distribution. It could be a median regression, for example, if you're trying to fit the 50th percentile. And I'll show you a picture of that in just a second. We also have the ability to now do some Poisson and negative binomial distribution where the dependent variable, again, is 0 inflated. Version 18 has both Poisson and negative binomial, but it did not handle the zero inflated case. So we have the ability to do that in doing the regression. We can fit a piecewise linear regression. I'll show you a picture of that in a second. And then we've also added the ability to fit stability models. A stability model is typically used to determine a shelf life, where you take a collection of data in various batches and try to estimate where the lines will cross some particular specification. Now, we've added a few things to the general linear models procedure. We've made it easier to enter interactions in second order terms. Rather than typing them all in now, you can simply tell it, give me all the interactions, for example. We've also added a stepwise variable selection that works with both quantitative and categorical factors. Now, we've had a stepwise regression in the multiple regression procedure for quite a while. We've now brought that over to GLM, where the particular advantage is you can handle categorical factors as well as quantitative factors. We've also added a new procedure for doing gauge studies. You know, there are quite a few procedures in Statgraphics now to do repeatability and reproducibility. However, there's a couple drawbacks. First off, in the older procedures, the data has to be balanced. Every operator, for example, has to measure the same number of parts the same number of times. Well, the new procedure in version 19 will handle unbalanced data, where some operators may measure more parts than others. The new GLM gauge study procedure also allows for additional factors beyond just operators and parts. Now, to show you a couple pictures of some of these new features, here's what a piecewise linear regression looks like. A piecewise linear regression consists of a number of linear segments which are continuous. They meet at a particular point. Well, the procedure in Statgraphics that fits a piecewise linear regression will now determine both the slopes and the intercepts of the two pieces. You tell it how many pieces. It could be 2, it could be 3. I told it in this case, give me 2. It also determines where they meet. You give it an initial estimate, you might say, I think they meet around 20 or something, but it will improve on that estimate. So what you get is 2 slopes, 2 intercepts, and the location at which they join. As I said, we added a stability study. That's the type of study that the FDA wants people to use to determine a shelf life. And in this case, I'm showing some data that was obtained from 5 batches of a product. Okay, it's actually the percent of the active ingredient in a particular drug, in this case, as a function of how many months it's been since the drug was produced. The way a stability study works is you model potentially each batch separately and then put confidence bounds around all of the batches, typically confidence bounds for something like P5 or P95. That'd be the 5th percentile. So basically, I'm 95% certain that no more than 5% of the samples of this particular drug are below that lower limit. And if you have a specification, for example, here's a specification of 90, the point at which that lower limit crosses the spec determines your shelf life. So it's a fairly standard type of procedure that needs to be used, that the FDA wants you to use to determine shelf life. Yeah, okay. I said we made a few changes to the general linear models procedure. One of the things, and I wanted to do this for quite a while, was to make it easy to enter interactions. If you're familiar with how that GLM model is specified in version 18, if you wanted interactions, you'd have to type them all in. A star B, A star C, A star D, and so forth. We now have a little ints button that brings up this particular dialog box, and you can tell it, give me all the second order interactions, give me all the quadratic terms, give me third order interactions, and so forth. It just cuts down the amount of typing that you need to do. More importantly than that, you see near the bottom that there's a stepwise variable selection now. And you can tell it to fit the entire model, of course, or you can tell it to do a forward or backward selection. Okay, and that's typically based upon P to enter and P to remove. One of the interesting options there, and I'll talk about this more in another webinar, is also the ability to retain lower order effects. You can tell it, for example, that if you're going to keep, let's say, the A-B interaction, make sure you have both A and B main effects in the model as well. So it's not a straight variable selection at that point. It'll leave insignificant terms in if they're involved in higher order terms, which is typically what a lot of people like to do. And then finally, you see the output of that new gauge study procedure. The changes, as I said, first, it will handle unbalanced data, but secondly, you can see that there's an additional factor here. In addition to operators and parts, I've also entered 2 levels of the coding. And in this case, it's optional, but I had coding added to the term for reproducibility and looking at that measurement error. Again, I'll be getting more into that in a future webinar. Okay. Now, one of the other things we've done, which I think is really interesting, is added an interface to Python. As I mentioned, version 18 had an interface to R, which is a free programming environment that a lot of statisticians like to use. More and more, though, we've had requests to add an interface to Python. So what we've done is basically duplicated the approach that we had used in earlier versions of Statgraphics to interface to R to now interface to Python. There's a procedure that will help you install the libraries that you need. There's a procedure that passes data back and forth from Statgraphics to Python. And there's the ability to generate and store Python scripts in your Statfolio. Okay. Similar to what we did for R, but now, as I said, there's a lot of interest these days, I think, in using Python. We're also starting to put in access to various machine learning procedures in the scikit-learn library. It's a very popular Python library, which has various types of machine learning algorithms. And the same way we interface to some of the R libraries, we're now interfacing to procedures in the scikit-learn Python library. As I think I showed you at the beginning of the webinar, I hope you had seen it, there is a tab at the end of the ribbon bar labeled Interfaces. Okay, Interfaces is where you go to install and configure Python to pass data back and forth, to execute scripts. And you can also see a link here to a k-means clustering procedure. That's one of the procedures in that scikit-learn library. Over here, you can see the various procedures that we've linked to in R, one of the new ones being actually a Venn and Euler diagram. I have a whole webinar, incidentally, scheduled to talk about the interface to Python, so I'm not going to go into much detail about it right here. Now, one of the things that we're doing with Statgraphics with version 19 is putting in more and more links to various machine learning procedures. In version 18, we put in our first machine learning algorithm, and that had to do with classification and regression trees. Machine learning algorithms basically are designed to make predictions. You feed it data, and it goes through some algorithm to then make predictions. In the case of classification and regression trees, it either classifies the data, puts observations into different groups, or it fits a regression model where it actually predicts the value of an outcome. Well, we've added in version 19 decision forests. What decision forests are is basically a forest of trees. Rather than just growing one tree as you would in a classification and regression tree in version 18, in a decision forest, you grow lots of trees. And you do it basically via bootstrapping. You know, you'll take a subset of the data, build a tree, another subset of the data, build a tree, another subset, build a tree. Subsets actually of both observations and variables. And you may build hundreds of trees. And then the final prediction of an observation is some sort of consensus of all those trees that you've grown. And this is something else I'll be talking about more in the future. But it tends to do better than just doing a single classification and regression tree. In terms of Python, we have in version 19 an interface to a k-means clustering procedure. A k-means clustering procedure will take a set of data and put it into basically k piles. You know, you'll tell it ahead of time, for example, divide this data into 3 groups. And using an algorithm, and there are various algorithms you can use, it will determine which observations go into each of the groups. Now, we had a k-means clustering procedure in version 18, but in that case, you actually had to supply what are called the seeds. You had to tell it, take you know, observation 13, 26, and 45 as the seeds for the clusters. And then it would put all the observations into whatever group it was most similar to. In this particular procedure, it automatically finds the seeds for you. So that's a particular advantage. I'm also in the process of working on support vector machines. That's another machine learning procedure. And that's going to come in version 19.2. Now, one of the things that we're doing in version 19, and I think you probably are aware of it, is we have switched from a perpetual model to an annual subscription model. And one of the reasons, well, there are a couple reasons for that. One is we want to be able to put new things out there for people on a regular basis. You know, I don't want to have to wait again, for example, 3 years to get enough together to justify a big upgrade fee. The ability to put new things in routinely is much easier to do if you have basically annual subscriptions. So it'll allow me, for example, to put the support vector machines in the program as soon as they're done. I'll call it version 19.2, and there's a couple other things we've also developed, which will be put into that particular version. The other thing, incidentally, that the annual subscription allows us to do, since we are doing more and more interfacing to R and Python, there's always the possibility that someone will switch input parameters in those R libraries or Python libraries. Okay, so I've always been a little bit worried that one of the developers in R or Python would change some parameter and break our code. It's not likely, but it's possible. With an annual subscription, basically, it allows us to make whatever changes we need to make and get it right out to people so that if there is a change, we can update it immediately. So we're doing more and more in the way of machine learning. Oh, this incidentally is a picture of the options for the decision forests. Well, I'm going to talk about this in another webinar, but you can see, for example, over here, I've asked it to grow 500 trees rather than a single tree. Okay. And then the k-means clustering procedure, some of the things that it does better than our older k-means procedure. You see it does over here a smart selection of initial seeds and has a lot more options for handling missing values than we had before. Okay. Now, some of the other enhancements we've added to version 19, we've added a few procedures for doing data visualization. I think I mentioned a moment ago that we've added Venn and Euler diagrams. We've added some new waterfall plots. I don't know if you're familiar with those, but those are sort of neat. I'll show you a picture in just a second. And someone had asked for an additional line on a bar chart, which actually, I'll show you a picture of that too. That's pretty neat. We've added some new statistical tests. We've added equivalence tests for standard deviations. We had equivalence tests for means in version 18, but now we have equivalence tests for standard deviations. We added a Wolfowitz test, which is used to compare two samples. It's a non-parametric test. And we've also added the modified Levene's test in the one-way analysis of variance. Last but certainly not least, we've added some important enhancements to the design of experiments. The two major things we've done in DOE, first off, we can now generate what are called alias optimal designs. An alias optimal design is a design that worries not only about the terms you have in your model, but also potential aliasing or confounding from terms not in the model. It sometimes turns out you can trade off a little de-efficiency, for example, and reduce the aliasing of effects not in the model fairly dramatically. I've also have a webinar, incidentally, scheduled to talk about these enhancements. And secondly, in DOE, incidentally, we now have the ability to take any design that's already been performed, any experiment that's already been done, and add additional runs to that experiment in an optimal fashion. So if you've done a 16-run experiment and you decide you want to do 4 more runs, we can tell you how to maximize, for example, the de-efficiency of the overall design, what additional runs you should add. Okay, just a couple pictures for you. That's a picture of a Venn and Euler diagram laying out the sets having to do with a deck of cards, an ordinary 52 plus jokers set of cards. Lines on bar charts. This I think is actually quite useful. When someone suggested doing it, I thought, well, that's interesting. This particular picture, incidentally, has the average high and low temperature in Washington, D.C. for January, February, March, April, and so forth. Those are the bars. The line is the average hours of daylight in that particular month. So you can see by adding a line on a bar chart, you can add quite a bit of information. Here are some of those waterfall plots. There's several types of waterfall plots: sequential plots, ordered plots, 3D plots. More than I have time to talk about here today, but those are some of the new types of graphs we've added. Here's the enhancements to DOE. As I mentioned, one of the options is to generate an alias optimal design. Just quickly, the way that works. Let's suppose I wanted to do a screening design, right? I have 8, 10 variables and I want to do a screening design. I don't want to include in my model interactions, but if there are interactions, I'd like to protect as well as I can against any confounding due to those interactions. So what you tell it something like this. You say, give me let's say a D-optimal design, okay? But I'll trade off a little of D-optimality. Maybe I'd be satisfied with 90% relative D efficiency in order to protect against aliasing due to two-factor interactions. And what it will do is it will generate a design. It may not be D-optimal, but it's close to D-optimal, and at the same time, however, protecting against interactions. Again, I'm going to do a whole webinar on that, so I don't want to go into too much detail. Finally, in the design of experiments, I talked about that computer augmented design. Basically, what you would do here is you take a design that was already done, tell it down at the bottom, you want to add, let's say, 10 runs to the design, and maximize the D efficiency of that design once those additional 10 runs have been added. Again, we'll have more on that in a future webinar. Okay, anyway, I've also done a whole bunch of videos for you. There is a video on our website, statgraphics.com, for each of the new procedures that we've added. If you go to statgraphics.com, look at the menu and you'll see a menu for instructional videos. Okay, you can also check the website. I've scheduled, I think it's either 3 or 4 more webinars. I'm going to try to do one every 2 weeks. The others will go a little bit more into depth on a particular topic. If you're interested in the data I started with, incidentally, it came from the COVID tracking project. It's a very nice website. They give you lots of information, covidtracking.com, and I thought I should mention it because that's where the data came from. Okay, now, one of the abilities we have in GoToWebinar here is the ability to answer questions. Okay, so I'm going to go back here and take a look and see what questions might have been submitted. I'll take as long as necessary to answer whatever questions you have. So if you would, if you have some questions, go ahead and send them to me. Okay, let's see. All right. I had some problems, obviously, with at the beginning with the audio and the screen, and I think we got that taken care of. Okay, now it's showing. Now finally got it fixed. All right, let's see if we've got some questions. The dashboard would be particularly useful when data is being received continuously from a source. Is there a way to that is true? That's sort of the way that we had intended it to be used. And I'm not sure how many people are aware of this, but we do have the ability to poll the data continuously. If I go here to data book properties, there's a feature in Statgraphics. I don't think it's used very often, but it's on the data book properties dialog box, and it's called stat link polling. You can tell the system to reread the data and rerun the procedures every, for example, 60 seconds. Okay. That would actually work very nicely with the dashboard, because what happens if you turn on stat link polling, and let's suppose your data is coming from an Excel file or something like that, right? You could have it every 60 seconds reread the data. And what it would do is it would rerun all of the background procedures and then update all of the output in the dashboard. You may have noticed, incidentally, when I put some things in the dashboard, I did so using paste link. Okay, the output in the dashboard is linked back to the analysis procedures. And if the analysis procedures change, the output in the dashboard will automatically change as well. All right. Question. Here's another question. Is there a way to tell whether a piecewise linear model is a better fit than a nonlinear model? I don't know that there's a formal statistical test necessarily. You do have R-squareds and adjusted R-squareds that you could use. That's part of the output of the piecewise linear model. And the mean squared error, I mean, that's related to the mean squared error. The lower the mean squared error, the better the fit. I don't think there's a formal statistical test we could do, though. Question, are all the data files you showed today available to us? Absolutely. I'm going to take this data file here and post it on the website as well so you can use it. It has data, I think, through October 31st. The COVID tracking project, actually through November 1st. The COVID tracking website updates it about 6:30 every night. So you can get up-to-date information on COVID-19 in the US. You know, how many people are hospitalized, how many people are on ventilators, how many people have died, and all that sort of information. It's the place most people go to get information about COVID-19. Here's another question. What about mixed effects models estimated by maximum likelihood, or REML? I guess I'm not quite sure in what context that's being asked. I'll have to look into that. What is the function of the transparent background? What is going to be accomplished? I don't know. Truthfully, I've never really used it myself, but that's something people asked for. They asked for the ability to go in to a graph and, for example, change the opacity. If you go to graphics options now, you see these little slider bars. You see these? That actually controls the opacity of the background, the extent to which you can see through. it was something people asked for. I guess some people like to be able to paste the graph down and see what's behind. It's something we could do, so I did it. I'm not really sure what the benefit is, but I'm sure somebody has an idea what they wanted it for. Could Statgraphics read from a database? Oh, absolutely. We haven't changed any of that. When you open up a data file, it gives you the ability to, where is, here, oops, no, that's not what I wanted to hit. I wanted to hit open data file. As always, you have the ability to do various types of queries. You can do an ODBC query or a manual SQL query. So we have the ability to, yes, to read from data files, databases as well as data files. Question, can you use interactive graph features while in the single pane mode? No. Okay, that's part of the reason that we did, we left the multiple pane mode. The idea, you know, if you were doing a forecast, hospitalized versus date, for example, let's call that back up again. The interactive type graphs, you know, where you move things around and query data points and that sort of thing, they're still going to be done in multiple pane mode. The single pane mode is just so you could get a better idea of what the layout of the output's going to look like if you publish it and so forth. But no, you'll still need to go back to the multiple pane mode in order to do the querying and that sort of thing. Question, can we perform the structural equation modeling since there's a new interface to Python? I'm sure it is available in Python. We don't have any particular link to structural forecasting, but we do have the ability to move the data over. And then I'm sure there's a library that in Python that does some structural equation modeling. I'd have to look into that. If a data point does not fit the correlation very well, it can be taken out by plus and minus. That's hard to do if you have thousands of points. Yeah, you saw me take out a particular outlier, right? By clicking on it and hitting the plus minus on the analysis toolbar up here. Someone's asking, is there a way that I could remove multiple points at once, maybe by lassoing them or something? The answer is no, not at the moment, but that would be a nice addition. Oh, here's someone talking about transparency. Neil, the transparency allows for overlaying an image, say health data over an image of a hospital. Okay, that sounds like a nice use of the transparent background. Okay, someone else is making a comment about how it would be nice to, you know, update, for example, the dashboard when you were querying data from a database. And that's absolutely possible. If you go to, again, to Databook Properties, you see at the top, it shows the source of data in various sheets of the data book. The COVID data is in a Statgraphics file, but it could as easily have been in a database. And again, the database can also be pulled periodically. A question, can we perform cross-validation for regression? The regression procedures themselves, I don't believe have that built in. Some of the new procedures you saw, for example, the classification and regression trees, those sorts of procedures have cross-validation built in, where you can actually, let me go back to the slides for a second. Maybe I can show you. Oh, whoops. Let me see if I can find that slide real quick. The one that has to do with the decision forests. The decision forests, GLM, no, interface to Python, machine learning. There it is. Okay. Shift F5, put that on the screen. In procedures for machine learning, like decision forests and classification and regression trees, you have the ability to define a training set if you want to. You can withhold a certain amount of data from the fit, and it will give you statistics on how well it can predict not only the data that are used to fit the model, but data that you've also withheld. There are some other procedures in Statgraphics that do also some internal cross-validation, where, for example, you withhold points one at a time, fit the model with all the other data points, and then give some statistics on how well you've been able to predict the points that you've left out. It varies somewhat from procedure to procedure. Now, we should do some more of that, I guess, in standard multiple regression too, because it gives you an idea of, well, it prevents you from overfitting your data, thinking you've actually built a better model than you have. Question, is it possible to increase the number of columns that can be joined together? Oh, yeah, we have an operators now for joining 2 columns, 3 columns, and 4 columns together. Someone wants to be able to join multiple columns together. Let's see, I don't know that we added anything new along those lines. You do know that if I go over here, for example, to edit, right, that's it, get the data sheet up. I do have an option to combine multiple columns into one. Okay, you can take, for example, if you had several columns and you wanted to put them into a single column, you can combine them and either stack them end to end or group by row. There are a number of different options. So if you want to put them one underneath the other, you should use this combined columns option here. It's on the edit ribbon under the data sheet section. See, this is part of the reason I like the ribbon bar so much. It makes a lot of these things more visible than they were before. Before, they were hidden under some pull down menus. Whereas now with the ribbon, you can really see all the different options quickly for the sorts of things you can do. Okay, that looks like that was the last question I had gotten. You're certainly welcome to send me via email, Neil, N-E-I-L, at statgraphics.com, any other questions that you have. We're also going to put this recording up on the website, and I do apologize for the beginning. We had some definite technical problems at the beginning, and I apologize for that. We'll try to make sure that doesn't happen in some of the future webinars. Okay, anyway, I ran a little bit over my hour, but please email me any ideas. You can go to the website, download a 30-day trial of version 19. You don't have to uninstall 18. You can have both 18 and 19 on your computer at the same time. So if you'd like to try it out, go ahead. Again, I enjoyed showing you what has been about 3 years worth of work, and I hope you'll come to some of the future webinars too. So long.